Hey guys, welcome back. In the last lesson, we played around with console producer and consumer, which are bundled with Kafka distribution. We learned a lot with that exercise, but I think it's time to step it up a notch. What do you say? Alright, in this lesson, we are going to write a producer from scratch in Java to ingest live RSVP stream from Meetup.com and push those RSVP messages into Kafka. Next, we'll write a consumer from scratch to consume the RSVP messages from Kafka and print it on the screen. If that isn't exciting enough, we will use Kafka Connect to consume the message from Kafka and save it to HDFS and write Hive queries against the data. Sounds exciting? Let's get started. I'm sure you have heard of Meetup.com. For those who are not familiar with Meetup.com, Meetup is a social networking platform that allows users to organize or join group meetings in various locations around the world. For example, interested in Kafka? Just search for Kafka and you will see meetups that are out in your location for Kafka. See, we have Kafka meetups all around the world. And organizers of these meetups will host Kafka related topics in the meetup. You can RSVP to those meetups and show up to the meetup and learn. When an organizer hosts a meetup or event in his group, members of the group gets invited and they can RSVP to the event. Meetup has a free API service that streams all the RSVPs that are happening live in their platform. You can see the live RSVP stream right here when you go to meetup.github.io/stream/RSVP ticker. Pretty cool, right? Furthermore, Meetup allows you to get RSVP data in JSON format. As you can see right here, just go to stream.meetup.com/2/RSVPs. I've copied a sample RSVP from the stream of data, and let's format the data to see how it looks like. I use jsonlint.com to format a JSON. Let's copy the JSON string I have, and let's scroll down a bit and hit validate JSON. And there you go. Here is the formatted JSON. We have the venue of the event first, followed by the details of the member who RSVP to the event. We have the RSVP ID here. We have the information about the event itself. And this event is to improve your public speaking and leadership skills in a supportive environment. And finally, you have information about the group itself. So let's look at the architecture of our application. And here is how our architecture looks like. Our goal is to write a Kafka producer to ingest stream from Meetup and convert each of the RSVP JSON data into a message and push it to Kafka. Once that is done, we'll write a Kafka consumer to consume the RSVP messages out of Kafka. And we'll run two consumers as part of one consumer group. Finally, we'll use Kafka Connect to get the messages from Kafka and save the messages in files in HDFS. Let's start with the producer first. You might think you may have to write a crazy amount of code to write a Kafka producer, but that is not the case. Let's take a look. Here I have a Java project named Kafka Meetup. So let's go into the source, open the package, and I have two class files here, one for the producer and one for the consumer. The producer is named Kafka Meetup Producer avro.java. So let's open this file. I'm going to maximize the screen here so we can get a full view. Let's start with the main method inside this class. And here is the main method. The main method simply calls a method runProducer. So let's go to runProducer. The first line of the runProducer calls a method createProducer, which is also inside this class. So let's go to the createProducer method. Here we are setting few properties. We are first setting the Bootstrap servers property to provide a list of Kafka brokers. Our producers will be reaching out to the brokers to get information about topic, partitions, leader information, etc. And the Bootstrap servers is a final variable which is defined right here. Next, we are providing an ID for the producer. We are naming it Kafka Meetup Producer. A message in Kafka is a key value pair. And we need to specify how this producer is going to serialize the key and value. We need to serialize the key value pair because we are going to send the data over the network to Kafka. So serialization is needed. Key in our message is not something which is important to us. We are just using the message count as the key. Kafka internally uses the key to decide which partition the message should end up in Kafka. Value is what we care about. Value will have the JSON that we get from Meetup. JSON can be represented as a plain string object. To serialize this, we can use string serializer and send the data to Kafka without an issue. But here, we are choosing to serialize both our key and value with Kafka Avro serializer. Why? Kafka, being an infrastructure in the middle, does not have any control over the data that is being pushed to it, nor it knows the structure or schema of the data. Avro file format is a great fit for Kafka because Avro file format embed the structure or schema of the data along with the data or the file. You can send complex or nested objects using Avro. Furthermore, you may now have a producer and consumer that is written in Java, as we see right here, but at a later time, you may have a consumer written in C++. When a Java producer is serializing a message in Avro, any type of consumer, let it be Java or C, will be able to consume the data with Avro APIs with no issues. And one more thing, later in the lesson, we will be using Kafka Connect to ingest data from Kafka to HDFS. And it is easy to work with Avro data in Kafka Connect. We'll see that in a bit. If you're not familiar with Avro, refer to the file formats chapter and we have dedicated lessons on Avro. Now back to the program. We are using Avro serializer to serialize both our key and value. The last property that we see here is schema.registry.url is used to point to the location of schema registry in Kafka. As I mentioned, Avro schema is embedded with file or data. Kafka uses an inbuilt schema registries to store and fetch those schemas. And finally, we are returning the Kafka producer, which we just created. We are saying both the key and value will be of type object. Now, let's go back to the run producer. In the run producer, we define the schema for our Avro record. The schema says the type of the record is record and the name is Meetup record. And it has only one field named RSVP and it is of type string. We parse the schema and then we get the Avro schema object. In the next few lines, we open a HTTP connection to the Meetup URL to stream the RSVPs. And we issue a GET on the HTTP connection. We then use the buffered reader to read the input stream. Up until here, we are just getting the JSON data from Meetup. Now we will be forming a record with the JSON data to send it to Kafka. Here, we are beginning to loop through all the data we get from meetup.com. Next, we read the JSON data from the stream, create an Avro generic record using the schema, and put the data we read from Meetup into a record. This record will become our value in our key value pair. Next, we create a producer record with the name of the topic where we will send our message along with the key value pair. And the name of the topic is hrw-meetup-topic and we'll be sending messages to this topic. Finally, we call producer.send record to send the record to Kafka. You can see here we are calling a get on the send, which means we will wait for a reply from Kafka. This way we will know if Kafka fails to save the message to a partition, we'll get an error back. It is important to note that messages are saved in buffer on the producer side and sent to Kafka in batches to reduce the I/O and improve the efficiency. Upon successfully saving the message, Kafka will send metadata back, which will have the partition number for the message and the offset information as well, which we will then print it on the screen. That is it. Our producer to get RSVPs from Meetup and sending the same to Kafka is ready. Let's now move on to the consumer. So let me open the consumer program, maximize this. Now that we understand the producer, understanding consumer is straightforward. We have a consumer named Kafka Meetup console consumer. The job of the consumer is to read the messages from the topic, get RSVP information from the RSVP record, and print it onto the screen. Simple. Let's start with the main method. Here in the main method, we are calling the method run consumer. So let's go to the run consumer method. In the first line of the run consumer method, we are calling the method create consumer. So let's go to that method. Very similar to the producer, we are setting some properties. First, bootstrap servers. Next, the consumer group name. So anytime we start a consumer, it will belong to the consumer group, HIRW Kafka Meetup consumer group. On the producer side, we specify Kafka Avro serializer to serialize the key and value. Here on the consumer side, we specify the classes to deserialize the key and value, and we will use Kafka Avro deserializer for deserializing key and value. Next, using these properties, we are creating a consumer with integer as the key and generic record as the value. In the next line, we'll subscribe our consumer to the topic, which is HRW Meetup topic. Finally, we return the consumer. Let's now go back to the run consumer method. We are starting an infinite loop here. Inside the loop, we are issuing a poll on the consumer. This is very important. This is the line of code where consumer issues a fetch request to Kafka to get messages from the partition. The parameter in the poll dictates how long in millisecond we are willing to wait for the messages to arrive in the partition for the consumer to consume. We have given a max value here, so we'll wait for a long time before the consumer gives up. If our consumer did not issue a fetch request, that would mean something went wrong with the consumer, and a rebalancing operation would be triggered by Kafka to assign the partitions handled by a stuck or dead consumer to other healthy consumers. And for each fetch operation, we will get a collection of records. So we will iterate through the records to get both the key and value. We are converting the value to a string, which will be the JSON string. Then we pass the JSON string to the parse RSVP function. The parse RSVP function is a utility function which will turn the string into objects so we can get group, event, and member information from the JSON string. And finally, we print the information on the screen, along with the partition number and offset. The last two commented lines are very important. Here we are instructing the consumer how to commit the offset of each partition it is processing. You can either do a sync commit or an async commit. If you recollect, sync commit will wait for the commit to complete and the processing will be blocked until the commit operation returns, whereas an async commit will not wait for the commit to complete and return. And alternatively, we can also choose to do an auto commit. And by default, auto commit is enabled and can be controlled with the parameter enable.auto.commit. And this would commit the offset every 5 seconds by default. To enable sync commit or async commit, we have to disable the auto commit by setting enable.auto.commit to false. Since we have commented both sync and async commit, we are going with the auto commit and it is enabled by default. So our consumer will commit every 5 seconds. That is it. Our consumer is ready. We are now ready to run both producer and consumer. And that is exactly what we'll do in the next lesson. This project is Mavenized, meaning we have listed all the dependencies for this project in the pom.xml file. So all we have to do is right-click on the project, run as, click on Maven build to build the project. And once the build is successful, copy the jar file to the location where we'll be executing the producer and the consumers. And we are now ready to run both our producer and consumer. And that is exactly what we'll do in the next lesson, along with using Kafka Connect to consume the messages from Kafka and ingesting into HDFS. See you in the next lesson.